What's up, math scholars and math haters? This is Mr. W. Today we're going to tackle question 9 in the 5th grade math questions that North Carolina released this past school year. We can see that we have an equation represented not with numbers but with rectangles that parts of each of them have been shaded in, and we're supposed to find the value of n, and our answer choices all look like this. It's a little weird, but we're going to make it through. Essentially, in order to do really well in a question like this, you'll need to know about equations and about fractions, specifically adding and subtracting fractions that have different denominators. Alright, so I want to start by just taking each of these two fractions, or taking each of these two diagrams and turning them into fractions. And I'm going to take my number of shaded spaces and put it over my number of total spaces in each one. So this one will be 2 shaded spaces out of 3 total 2/3. And I'll go ahead and write in my plus and equals. And now, let me make sure I can count this right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4, 5, 6, 7, 8, 9, 10. Out of 11, 12. Alright, so I've taken each of my pictures and I turned them into numbers. I know that 2/3 plus some variable that I don't know what it equals yet equals 10/12. And it's at this point that I'm going to break out my fact family tricks, and I'm going to say that if I know that 2/3 plus something equals 10/12, then 10/12 minus 2/3 equals that something that I don't know yet. The reason why I left a bit of space here is because now we have a subtraction problem with two fractions that have different denominators. So the first question that I want to ask if I see two fractions with different denominators is, does the small denominator go into the big one, does the small denominator go into the big one evenly? And if it does, how many times does it go into the big one? So how many times does 3 go into 12? Well, the answer is 4. 3 times 4 is 12. So I'm going to say times 4 times 4, and this is going to get me an equivalent fraction 2/3. 2 times 4 is 8. 3 times 4 is 12. So now I'm looking at 10/12 minus 8/12. And at this point, I like to break out my analogy that if I'm doing 10 inches and I take away 8 inches, I'm left with just 2 inches. Nothing happens to inches, and so we're going to do the same thing when we subtract these two fractions. I'm just going to do 10 minus 8, which is 2, but then I'm not going to do anything to the 12ths, because the 12ths is like the unit of measurement here, kind of like inches was the unit of measurement in this quick subtraction problem with the same numbers. So 10/12 minus 8/12 equals 2/12. At this point, I need to simplify this fraction now. And I need to see what number goes into both 2 and 12. That number is 2. So I'm going to divide by 2, divide by 2. 2 divided by 2 is 1. 12 divided by 2 is 6. So my answer is 1/6. Now all I need to do is just make sure that 1/6 actually matches one of my answer choices. So I'm going to go ahead and just go through and translate each of these into a fraction. And I'll give us a little trick for C and D as well. All right, so for A, I have 1 part shaded out of 2, 3, 4, 5, 6. So 1/6, that matches this. I'm going to be reasonably sure that that's my answer, but I want to test the others just to make sure. All right, now for part B, I have 1, 2, 3, 4 shaded out of 5. Not what I'm looking for. For part C, this one is split into 3 pieces, so I'm going to go ahead and split this one into 3 pieces as well. And I'm going to say I have 1, 2, 3, 4 out of, and since each rectangle is split up into 3 pieces, this needs to be 4 out of 3. Either way, it's not what we're looking for. And now I'll do a similar thing for D. 1, 2, 3 pieces out of, and each rectangle is split up into 2. So this is 3 halves, not what we're looking for. The only answer left that we can work with is A, 1/6.